Hey everyone, welcome back. Today's our topic of discussion is dispersion. Dispersion, as the name suggests itself, is the difference between each value in the data set to that of the central value. The central value can be arithmetic mean, median, mode, geometric mean, or harmonic mean. Dispersion helps us quantify the difference between each individual value from the central value and also the difference between two individual values. Let me explain with an example. Suppose this is my data set. I have three values x1, x2 and x3. The central value, which may be arithmetic mean, median, mode, geometric mean or harmonic mean, may be x bar. So I consider x1, x2, x3 as the three values in the data set and x bar is their mean. Now, dispersion helps us know about the difference between x1 to x bar, x2 to x bar, x3 to x bar, and also the difference between x1 and x2, x2 and x3, and x1 and x3. So simply, dispersion helps us find out how the data is spread throughout the data set. This helps us find out the variability of the data. We have generally four measures of dispersion: range, quartile deviation, mean deviation, and standard deviation. These four are called as the absolute measures of dispersion. They give you the exact value of the difference between the values and difference of each value from the mean. Whereas there are relative measures of dispersion as well, where we find out the coefficient of each of these absolute measures as well. Now, let us delve deep into each of these measures of dispersion with help of some examples in case of individual, discrete and continuous series. The first, simple and quickest measure of dispersion is range. Range helps us in finding out the outliers of the given data. That is, the extremely largest value of the given data and the extremely smallest value of the given data. It helps us find out the outliers. And also, we can remember that it gives us a quick glance of how the data is spread throughout, because it depends only on the two values, the maximum value and the minimum value. That is, the data first need to be arranged in a chronological order from smallest to largest and find out the highest value of the given data and the lowest value of the given data to find range. Let this be the example for individual series to find range. We know that the formula for range calculation is maximum value minus minimum value. In this data, we need not find the number of values and all. Simply, we need to find out the maximum and minimum values of this data set. This is the minimum value 13 and this is the maximum value 34. So the range will be 34 minus 13, that is equal to 21. So 21 is the range of this given data set. This is just the absolute measure. Now let us see the relative measure of this, which is called as coefficient of range. Coefficient of range is equal to largest minus smallest divided by largest plus smallest. Largest minus smallest is 34 minus 13 divided by largest plus smallest 34 plus 13, that is equal to 21 by 47, giving the value 0.44. So 0.44 is my relative measure of dispersion, that is coefficient of range, and 21 is my absolute measure of dispersion, which is range only. Now let us calculate range and coefficient of range in terms of discrete series. Let us consider this example for the calculation of range in discrete series. We have ages of 1, 2, 3, 4, 5 ages, and the number of children of each age is 20, 19, 6, 51 and 87. To calculate range in discrete series, we will not consider frequencies. Frequencies play no important role in calculation of range in case of discrete and continuous series. We are concerned only with the values of x in case of discrete and continuous series for calculation of range. The maximum age value here is 5. and the minimum age value here is 1. So the range will be maximum value 5 minus minimum value 1, that is equal to 5 minus 1 is 4. Range is 4, which is the absolute measure of dispersion. For coefficient of range, our formula will be maximum minus minimum divided by maximum plus minimum, that is 5 minus 1 by 5 plus 1, which gives the value 0.66. The main difference here you need to remember is, in calculation of range, for discrete values, you need not consider frequency. Frequency will not play any major role. Similarly, in continuous series also, frequency is not going to play any major role in calculation of range. This is my example for continuous series to calculate range. The class intervals are given, 4 class intervals, 15 to 19, 20 to 24, 25 to 29 and 30 to 35. Their respective frequencies are given. But already we have discussed that for calculation of range, frequency plays no important role. So I simply will not consider this. For the complete data, the ages or the class intervals will start from 15 and ends at 35. So we know the lower limit of this particular data set 15 and the upper limit of this particular data set to be 35. So my 35 will be the maximum value and 15 will be the minimum value. Simply substitute in the formula for range to give range is equal to max minus min, 35 minus 15, that is equal to 20. This is just my absolute measure. To calculate the relative measure, I'll use the formula L minus S by L plus S. So 35 minus 15 by 35 plus 15 to give the value 0.4. In this case, my absolute measure will be 20 and the relative measure will be 0.4. I hope you understood what range is and coefficient of range is. We have seen that range is simple and quickest measure. At a glance, we can understand what the data is and how it is spread. It just gives us an idea how the data is spread, and it simply depends upon two values. But what are its cons? What are its demerits? Depending only on two values of a given data set and drawing conclusions can be incomplete. It only takes two values, which does not give a complete information, does not let you know about the distribution, does not let you know about the shape. So that is the reason we move to the next measure of dispersion, which is called as quartile deviation, where 50% of the data is considered.